Okay, good afternoon. So we continue the lesson. So this is the most important part of our lesson in this chapter. We want to be able to simplify rational expressions working with them. So rational expressions are algebraic expressions in which you have a fraction whose numerator and denominator are polynomials rather than numbers. So if you know that a number is called a rational number. For example, 2 over 3, I call it a rational number, yes? This is a rational number. But when I say a rational expression, I mean a fraction again, so that its numerator and denominator are algebraic expressions, or to be more precise, they should be polynomials. For example, 2x plus 5 to and x minus 3. This is a rational expression in one variable. It's a fraction, its numerator and its denominator are polynomials. Okay? Of course, there are some limitations. You know that because x is a variable, then I have to be careful sometimes that x cannot be 3. So this is always defined because I see with my eyes that 3 is not 0. But here x minus 3 might be 0 if I choose x to be 3. So when I talk about this rational expression, I implicitly mean consider this when x is not equal to 0. So whenever we are working with rational expressions, we are working on their domain. The domain means that I do not have any problems with them. Yes, so that's important to know. So the first thing that you want to realize with rational expressions is how to simplify them, exactly as we simplified fractions. For example, if I wrote 4 over 6, instead of working with 4 over 6, you can divide the numerator and the denominator by 2 and you get 2/3. But to be very careful is that if you want to do this, you factorize 4, you factorize 6. Factorize means writing this as product, and then you cancel out the common factors from the numerator and the denominator. So this was so simple for us that we even didn't care about writing the factorization. We did it in our head, yes? But for the case of rational expressions, you have to spend some time to factorize the numerator and the denominator. So in principle, simplifying a rational expression is 2 factorization problems. Factorizing the numerator and factorizing the denominator, and then of course distinguish which ones are in common and cancel them out. Yeah, so that is the main thing. So here I want to make sure again that you are not tempted in any ways that you can simplify this x with that x. This is the common mistake here. It's not possible. It's not possible. Even if I have this situation, I have seen some students think in this way. That is not correct. Yes, I cannot, when I want to add 2 fractions, I am not allowed to add the numerators and the denominators separately. So these are the things that you have to be careful not to make mistakes. But other than that, this is just factorization problem. And I can teach it I can teach this to you only through exercises. So I will start writing and try to do things. Of course, the next lessons, which probably will cover some part of it today as well, we want to do operations with rational expressions. I want to learn how to multiply rational expressions. I want to learn how to divide them. And the hard part is usually for students is how to add them or subtract them. Because then you have to find the common denominator, but the common denominator for numbers are fairly easy for you. You have to learn how to find the common denominators for rational expressions containing algebraic polynomials. Yes? More than? Yes. So for example, that is the same question as you can have here. For example, do you consider this a rational number? Yes, is that your question?
No, but like if we had 2x plus 5 over x plus 2 over 3.
Yes. That's also a rational expression.
Okay, and like can you do any operations?
No, in principle, you shouldn't have search signs.
But like you could have a multiplication that would just
Yeah, so here in the rational expressions, yes, you can do whatever you like to. but of course this topic is if you want to be honest, the definition of a rational expression, for example, as soon as you see a fraction you cannot call it a rational number, because you might have a fraction like this. The fraction like this is also not rational. So here also the same situation. When I talk about rational numbers, I mean fractions whose numerator and denominators are integers or can be written in the form of an integer. And here when I say rational expression, I mean fractions whose numerators and denominators are polynomials.
But it's not that we have two different fractions. You wouldn't say that we have two different fractions. Yeah.
No, but I mean for me this is also a rational expression. I don't know, 2 over x plus 3 over x squared. That is considered also a rational expression. Yes, because the reason that this is a rational expression is that after being simplified, it can be reduced to a one single fraction whose numerator and denominators are polynomials. Exactly like that. Okay. Okay, so the question here, the first thing that I want you to learn good actually is how to simplify. So I will start writing examples, okay? Simplify example. And I always mean in the domain of the variable involved, even though I do not mention it. So simplify. For example, I will have 4. So let me start from here. X to the 4 minus 9x squared divided by x to the 4 minus x to the power of 3 minus 6x squared. So I want to simplify this rational expression. It's a rational expression because it's a fraction and its numerator and denominators are polynomials. Okay, so the first thing that comes to mind is to factorize the numerator and the denominator. If possible, do them in parallel. But if the problem is hard enough, you can start factorizing the numerator and finish it separately and do the factorization for the denominator and then transfer them into one single fraction and simplify them. That's up to you. But because this problem is not that hard, let us do the factorization. So when I see this rational expression, I want you to understand that none of these x's here or without can be simplified with any of these x's. Nothing can be done right away. Okay, so I have to factorize the numerator, but this is simple. I told you the priority in factorization, if there is something in common in all terms, that has the priority. Do that and then think what happens. So here I see that x squared is in common, I factor it out. Yes. Here, what can I do? You can continue this until this finish, but let us do them in parallel. It's not a hard problem. So what can I do here? What's the first step? Yes, because there is something in common again in all the terms that has the priority. So you factor it out. So this becomes what? X to the 2 minus x minus 6. But by the way, the good news here is that you really don't need to fully factorize. For example, if for some reason this becomes x squared minus 9, even though x squared minus 9 is not fully factorized yet, but why should I care? Because x squared minus 9 and x squared minus 9 will go away, so I don't need to bother to fully factorize them. So be observant about that. So your strategy here is not factorization. Factorization is helping you to do the simplification, but don't lose the logic. The logic is to get rid of factors. But of course, for example, can I get rid of x squared right away? Yes, because x squared is a factor of the numerator. Why? Because it is being multiplied, and it's the same here. So that's a common factor, so I can cancel it out. When I say cancelled out, what is left instead? 1, which we don't bother to write from now on, but remember, that is 1. Okay, but is the factorization, so either I have to live with it. It's simpler than the previous version, of course. But if it is possible to simplify it more and you stop here, you will lose some points. Can I continue? yes, might be you factorize and you see that nothing is in common, okay, but that is what it is. You need to live with it, okay. So x squared minus 9 can be factorized using the conjugate rule. But what about the denominator? I think you have enough experience. This is a quadratic trinomial and the simple one, okay. So it is better to start guesswork rather than going through that long process of finding the roots first. So you put an x here, you put another x here, you ask yourself, I need two numbers whose sum is this number, -1, and the product is -6. So what are those numbers? -3, +2. Yes, so I put -3 here, +2 there. But is there something that I can cancel now? Yes, x minus 3 and x minus 3 are common factors for the numerator and the denominator, so I can cancel it out. What is left in the numerator is x plus 3. I don't need any pairs of brackets anymore, so I just simply write x plus 3, x plus 2. But it is extremely important to tell me, can you simplify these x's right away now? No, because they are summands. They are not factors, so that's the end of the problem. So this expression can be simplified to that expression. Okay, and it's extremely important, by the way. It's good to improve your algebraic skills. Yes? Okay, so yeah, that's it. But let us try to solve some problems together, okay? For example, I ask you to simplify this. 6x cubed plus 3x squared minus 3x divided by 2x squared plus x minus 1. Okay, so that's a quadratic trinomial. Might be we need to factorize this, but don't be in a hurry. So what is the first step you do here? What should I do? Yes? Mm-hmm. Yeah, because you see 3x is in common all of them. I told you this always has the priority. So this becomes 3x. And what is left from here is 2x squared because I divide it in my head. This becomes x. And then this becomes minus 1. And the denominator, you see, you should be able to look a little bit ahead of you. Do I need to bother to factorize this? Yeah, even if it is possible, I don't know. So it's not a very friendly polynomial to factorize, but I don't need even to think about it, because this expression appears as a factor in the numerator, and that is the whole denominator, so that's considered to be the same factor for itself. So this considered is a common factor, so I cancel it out. By cancelling out, this is 1 and 1 is left, but 3x times 1 is just 3x, and the denominator is 1. We don't bother to write that. So this expression is exactly equal to 3x. So why should I work with this horrible fraction rather than working with 3x? So this is important. But let me ask you something. Do you think we can factorize this? Assume that this is coming in the factorization question. So can I factorize that? I want to practice this. It is not necessary for this problem. First of all, do you remember that trick? If you are doubting, calculate delta. Yes? So delta is what? 1 minus 8, which is 9. As soon as you have a perfect square, complete square, it means that this is factorizable. If it is not a perfect square but positive, it is factorizable, but not in the realm of integers. You have to deal with the square root signs and things like that. And if the delta turns out to be negative, forget about it. It is not possible to factorize it. Okay? So, but then here, do you remember that I told you the trick? So if you want to use that fast trick, you need to break this one into two pieces. Yes, so let me just do this here again. You ask yourself, I need a number, two numbers whose sum, two integers to be honest, that this is 1, and the product is the product of these numbers, which is minus 2. What are those numbers? Positive 2 and negative 1. So this indicates that I need to break the middle one to positive 2, negative 1. Yes? and then you see that 2x minus x is x. Between these two, I factor a 2x out. It is x plus 1. And then between these two, I factor a negative sign out. It becomes x plus 1. So I can factor x plus 1 to x plus 1. Some of students are actually very good in guessing things. Just guess. Be my guess, yes? So, but this is the way that if you want to do a little bit more work, you can just do it. But I want to understand that it is a waste of time for the purpose of this problem to factorize this and factorize this, because it is already gone. Okay? Okay. Let me write another example. So I want you to simplify this. I want to give you time here, because there is nothing I can teach you that much. You have to practice yourself. So I will write two examples here. One, xy plus 5x plus 7y plus 35. This is a polynomial in two variables. And then divided by y plus 5. So you just start immediately doing that. And then I would write one more here for you. So 2x squared minus 11x plus 5. And then I have 6x squared plus 5x minus 2. I can write one more and then we can solve them together. So a to the 6 minus b to the 6 divided by a plus b, a to the 3 minus b to the 3. So I give you 5 minutes. I think that would be enough. Yeah, the middle one in this one is minus 4. I made a mistake when I wrote minus 2. It's not a mistake. I mean that it's not interesting. You cannot simplify that much if I write minus 2. Okay, so what can I do for the first one? For the first one, the denominator, hopefully you agree with me that there is nothing we can do about the denominator. Yes, so I just copy and paste that part. But this is the lesson we learned yesterday. If I want to factorize that, what is that trick? You're just grouping them and factorize them separately. Yes. So I don't know which one do you prefer. So let us take these two together and these two together. Yes. So between the first two, I take x out. It becomes y plus 5. And between the other pair, I take 7 out. And this is successful grouping, because now you see a new common factor emerges and I can pull it out. But can I go further here? Yes, because y plus 5 is the only expression in the denominator, so that can be considered as one single package or factor. And that's also a factor. This and that are common. I divide, so this becomes x plus 7 over 1, but I don't need to write it down. So this expression is simply x plus 7. There is no difference. There is one difference. Let me just point you again. So by the way, this is interesting, because what I calculated, that it becomes independent of y. So it doesn't matter what you choose for y. If you are patient and calculate it, the calculation shows that it doesn't depend on the y that you choose. It only depends on the x that you choose. This is something interesting. So I mean, this is in principle something depending on both x and y. So it should be affected by my change in x and my change in y. But this calculation confirms that it doesn't matter what you choose for y, but there is one exception. When I say that one is equal to that one, not always, yes? Y is minus 5. So if y is minus 5, this is not a number at all. Because if it's minus 5, the denominator vanishes. So as far as I choose a number, not if I choose something except minus 5 for y, then this expression is equal to this expression, and then it doesn't matter at all what value I choose for y. It only depends on the value of x. So this is why sometimes remember I might ask you in the exam, show that this expression is independent of y. What I mean to simplify that and show that y can be cancelled out. That's the meaning of an expression independent of one variable. Okay, so that's good. For the next one, you know that you are facing two trinomials with having this coefficient here. So I myself prefer to do this separately. That's up to you how you want to do that. First, I focus on the numerator and I ask a question from myself. Can I find two integers whose sum is negative 11 and the product is the product of the first and the third numbers? The product of the first number and the third number is 10. So then I would say that if the numbers are small, I might be able to guess. So I will not bother to go through that process, long process. So can you tell me what are these? So okay, so what I can do, I can break the middle one to, what did you say? Minus 1 and minus 10. So I break the middle one to minus 1 and minus 10. Yes? Yep. No, no. Breaking terms, if I want to say, yes. But okay, now I will take these two, for example, together, and these two together. Between these two, I can pull x out, so it becomes 2x minus 1. Between these two, I do not take 5 out, because I want to have the same factor emerging. I take minus 5 out. And then this negative 10 becomes positive 2x as I desire. This positive 5 turns out to be negative 5, a negative 1 as I wanted. So that is successful grouping, yes? Because now you see that this is a common factor emerging, so I can write 2x minus 1, and then I would write x minus 5. So I will put it in a box. This is my numerator. Okay, so let me just put n, capital N for numerator. So I calculated my numerator, I got that. Not calculate, sorry, I factorized that. Okay, I go to the denominator now. So for the denominator, I need to ask another question. I need two integers if possible, so that the s is how much? Is 5, but what is the product? Minus 24. The product of the first and the last number. Can you guess those numbers? No, plus 8. Yeah, plus 8 minus 3, yes. Plus 8 minus 3. Yes? So I will break the middle term to plus 8 minus 3 x and minus 4. And then I group these together, for example, these together. Between these two, I can factor a 2 and x out. So what is left here is 3x, and then I have 4 here. Between these two, I just factor a negative sign out. It becomes 3 plus 4. So let me put d for denominator. And this is a good trick, because now I have this common factor emerging. I pull it out, and then it becomes 2x minus 1, yes? So my numerator, my denominator. So the whole expression is equal to my numerator divided by my denominator. So what was my numerator? It is 2x minus 1 times x minus 5. I divided by 3x plus 4, and then 2x minus 1, yes? And then you see that this factor and that factor are cancelled. And then what is left for me is x minus 5. And what is left here is 3x minus 4. Can I 3x plus 4? Can I continue simplification here? No, so that's the end. So x minus 5 and 3x plus 4. I have seen students come through this right and then simplify these x's, so that becomes totally wrong. Okay, then I am confused, because if you couldn't understand, why did you do so great up to then? And if you understand, why did you cancel x out? Yes, so that would be a puzzle then. Okay, this is good. What about the last one? What is your suggestion? Conjugate pattern. So what I do as the conjugate pattern, so it becomes what? A to the 3 minus b to the 3. I don't need to do them separately. And then a to the 3 plus b to the 3. And then I have a plus b, a to the 3 minus b to the 3. Yes? Okay, can I simplify something right away? Yes, because this one and that one are factors and are in common. And then I'm left with this, a to the power of 3 plus b to the power of 3 divided by a plus b. Okay, what do you think now? Yeah, I told you that these rules are always in the formula sheet. We talked about that before. So the sum of cubes and the difference of cubes can be factorized even more. Yes, so what can I do? Do you remember the formula? If not, you have it in the formula sheet. So it becomes a plus b, a squared minus ab plus b squared. That is the numerator. And then I have a plus b. Can I simplify something? Yes, a plus b and a plus b are totally gone. So that's just simply a squared minus ab plus b squared. So this expression is actually simplified to that expression if it is meaningful. Meaningful means that a plus b is not 0, a is not b. Sometimes you have to deviate a little bit from this standard procedure. For example, let me write another example. I mean, the whole point is factorization, but sometimes you have to simplify so that you are able to factorize, okay? Or let me just give you a very simple example here. For example, I give you this, and I write a minus b to the power of 2 plus ab. Okay? I think it's not harmful if you are working with these things a little bit more than usual. Yes, because that's a simple problem. You just have it in the formula sheet. So remember, the sum of cubes can be factorized. The difference of cubes can also be factorized. But when it comes to power 2, only the difference can be factorized. Okay, so, but if I factorize that, so let me just write the factorization here. So it's a plus b, and then I have a squared minus ab plus b squared. Okay, then what? If I just want to copy and paste the denominator as it is not wrong, of course, 100% correct, but I cannot simplify anything more. And I do not have any idea how to factorize this, or unless you have it, okay? So that's the only thing. That don't lock your brain to one particular strategy, because it will prevent you not seeing the others, yes? So, okay, apparently we cannot do that, but we can do something. If you want to do something with it, what do you do? Yes? Expand it. Also just do that, even though it is a little bit deviation from the general strategy of factorization, yes? But sometimes it can happen that you expand, the expression becomes simpler. When it becomes simpler, you can then factorize it. This is one of those cases. So this becomes a squared minus 2ab plus b squared, but I have a plus ab here. Simplification is not finished yet, because you first simplify and then try to factorize. The factorization of the numerator is already done, so I just copy and paste. Okay, and then here, this ab positive minus 2ab, they can combine. And then you realize that I don't even need to bother about factorization anymore, because whatever appears here is the same thing there, they are cancelled. And then what is the answer? The answer is a plus b. Okay, let me write two ones. They are a little bit challenging. I want to give you time to think, and then we can come back and solve them, and then we can move probably to the next lesson. And the next lesson is still multiplication, addition, subtraction of these rational expressions, and they are extremely important. So let me write two for you here. So one is c squared minus a squared minus b squared minus 2ab divided by a plus b plus c. Okay? I want you to simplify this as much as you can. You continue until I am writing the other one. Don't waste your time here. Yes, I want you to simplify these rational expressions. Do you have any idea what to do for the first one? Yes, Rasmus? Yeah, yeah, exactly. So between these three, I can factor a negative sign out, yes? So then this becomes c squared minus, this is one of those cases you have to group three of them and one alone, yes? We had these kinds of problems yesterday, if you remember. So this becomes a squared plus b squared plus 2ab and then divided by a plus b plus c. But then everyone agrees that this is a squaring rule, so this becomes c squared minus a plus b squared and then divided by a plus b plus c. Okay? Okay, then what? Yes? Yes, c squared minus, that is a conjugate pattern, but you have to make sure that you are not missing minus signs and things like that. So I would prefer to do it in two steps. I would write the square root of the first one minus the square root of the second one. If you write like that, that is wrong. You have to be careful or do it in your head properly. And then the square root of the first one plus the square root of the second one. And then divide it by a plus b plus c. Just one more step. I can just remove these unnecessary pairs of brackets, so it becomes a minus b, and this becomes c plus a plus b, and then divided by a plus b plus c. Can I simplify something here? Because this a plus c plus a plus b is the same thing as a plus b plus c, and here it appears as a factor, so I can cancel it out. And then what's left? 1 is left here, 1 is there, but no one bothers to write 1s, so it just, that's your answer. So it's c minus a minus b. So what about the other one? What about the other one? The other one is also, the idea is similar, but the algebra is more complicated, yes? Immediately you see a conjugate pattern in the numerator, yes? So what I do, but be careful not to make mistakes. So I take the square, so I will write two big pairs of brackets here. So let me just put them here. The square root of the first one minus the square root of the second one. So this becomes a squared plus b squared minus c squared minus a squared minus b squared plus c squared. And then once the same thing but with positive sign in the middle. So this becomes a squared plus b squared minus c squared plus a squared minus b squared plus c squared. What can I do for the denominator? Because it's better to do them in parallel. I can immediately see that the denominator can also be factorized very simply. Why? Pulling 4a and b out. Yes? So I pull 4ab out. What is left from here is just one single b, and what is left here is just one single c. Okay, I don't know. Is it possible to simplify it better? So let us see how it goes. Okay, so now I remove the unnecessary pairs of brackets. So here I don't need to be worried. So let me just write it in 2 steps if you want to read it in the future. So I apply the minus sign in, so it becomes minus a squared but positive b squared minus c squared. And then the other one, I just remove the pairs of brackets without any changes. Nothing is behind them. That's also positive. Okay, and then we just copy and paste the denominator as it is. So one more step is to simplify things. So you see minus a squared, whatever it is, and that's gone. So I have b squared minus c squared. Let us just do it patiently. So it's plus 2b squared minus 2c squared. And then here what happens? B squared and b squared are gone. Oh, c squared is also gone. Yes. And then there is 2a squared left. Yeah, that's a good problem. So it simplifies a lot. So this becomes 4ab. And then this is not c, by the way. This is brackets, yes. So 4ab b minus c. I know that what we are supposed to do now. These two, let me just do it patiently. So 2a squared is here. Between these two, I factor a 2 out, which will be multiplied by that 2. It will give me a 4. This becomes 4. And I write a squared here. And then what is left for me is b squared minus c squared. And the denominator is 4ab minus c. So this 4 and that 4 are cancelled. This a with one of these a's are cancelled. So what is left for me in the numerator is a, but that's also a famous pattern again. So this becomes b minus c, b plus c, and then in the denominator I have b and b minus c left. Yes? And again b minus c and b minus c are gone. So what is left is a times b plus c divided by b. So that is the simplified version. But to be honest, if it is not possible to simplify anything, in principle you have to write it in the expanded form, even though if you stop here, that's okay with me. I realized that nothing can be simplified more, so I just multiplied back. So it's AB plus AC. But this last step is not unnecessary and sometimes subjective. Some people prefer to leave it like that. Some people prefer to write it like this. Okay, so that's a good question. You see, that expression we were able to simplify it quite a lot. You see? So that's one thing that I want you to learn very good. This is very, very important. For your future in mathematics, to be able to simplify horrible expressions to very short forms. Okay, I think this is enough, but now we start doing some more teaching, a little bit at least. There are operations that we want to learn, is a multiplication, division, addition and subtraction. Multiplication of division is actually, to be honest, nothing. That's the same problem. Why is that? Because whatever rule you have for, let me just review a little bit. If I have two fractions, just numbers, I ask you to multiply them. What is the base rule? You multiply the numerators and put them in the numerator. You multiply the denominators and put them in the denominator. Okay, but it's for numbers, it doesn't matter that much if you actually do this. By the way, sometimes it matters. For example, if I want to calculate this, okay, of course the crazy way to do it is just to sit down and multiply these two numbers, and then divide them. But so before doing that, you can say that, okay, if I multiply them and I am patient, okay, and then I realize this is a factor that is gone, that's also gone, so that's 1. So this means that, you see, this 121 which appears here is simplified with this 121 which appears here. So what I want you to learn is that if you have a fraction, this can be simplified in this vertical manner. These two can also be simplified in the vertical manner, but more than that, because you see that D can also be simplified with A in the crossway manner. This also can be simplified if I have common factors. This can also be simplified in that way. So this is extremely important. In numbers, that's not a big deal. You have the calculator in front of you. But if I want you to change your mentality to this. People usually multiply and then simplify. But it is extremely important, especially when it comes to algebra, try to simplify and then multiply. Because it is very much more efficient if you get used to this way of thinking. Of course, the final results are quite the same. Okay? But efficiency is not the same at all. Assume that I really want to, this is under 1 second, I understand that this product is 1. But if I want to multiply, then I have to spend a lot of time to multiply them. Okay? Okay, so this is the trick I want you to learn. And then, of course, division. Let us also let me just give you an example of multiplication, and then we also go to division. Okay, for example, if I give you this x squared minus x minus 2 divided by x squared minus b squared, and you are supposed to multiply this by a squared plus ab divided by x minus 2. Okay? So if you face a multiplication between algebraic rational expressions rather than fractions, numerical fractions, what you do, you just do the same thing. You start factorizing everything that is there. So I have 2 numerators should be factorized, and I have 2 denominators should be factorized. So you see that factorization is actually a very vital, important part of this lesson. So okay, so let us just do that. So I change my color for the solution. So what I do, I start factorizing this. But this is very simple. This is a very standard one for you. So this, I put x and x here. I need 2 numbers whose sum is -1 and the product is -2. So it's -2 and +1. Yes? And then you really immediately recognize the pattern here. That's the conjugate pattern. So this becomes a minus b, a plus b. Multiplied here, it's very simple. The only thing that I can do is pull an 8 out. And this is x minus 2. So this is how it is. So I just started immediately factorizing all the things that I have. And then I need to think in this way, vertical manner of simplification, and also cross manner simplification. Is it possible to do this any simplification vertically here? No, because there are no common factors. Can I do vertically here? No common factors. Okay, but can I simplify something from the numerator of this one with the denominator of the other one? The answer is yes. So I will do that. Yes? And then can I simplify something from the denominator of this one with the numerator of the other one? The answer is again yes. And what do I mean by these cancellations? What is left for me? Because it is a division. It's 1. And now after simplification in both manners, vertically and cross manner way, are finished, then I start using the rule. Multiply the leftovers in the numerator, multiply the leftovers in the denominator. So this is 1 times x plus 1 times a times 1. So it goes to the numerator. So this becomes x plus 1 times a. And then a minus b times 1 times 1. So it's just a minus b. Can I simplify more? No. This a cannot be simplified with that a. So I myself prefer to write it back in the expanded version. But that is up to you. You can stop just there. So this is the final answer to this. Yes? Okay, let me also give you the lesson for division, because that's also nothing. The important thing is subtraction and addition. I will spend more time on that. But what about the division? Do you remember the rule? If you want to divide a fraction AB divided by CD, what is the rule? You just write the first one and turn this into a multiplication, and then you have to swap these two. Yes? So in principle, this is not a new lesson at all. You need one more step. Change division to multiplication and swap these two. And then the problem of division reduces to the problem of multiplication, and that is the lesson of multiplication. Yes? So let me just write one example, and that would be the last example for today. But we will actually 2 more sessions, or might be 3 more sessions I will spend on rational expressions. Okay, so for example, 4x squared minus 9a squared divided by ab minus minus a squared, again divided by 2x, and this is not a2, this is a4. And this is 2x minus 3a squared divided by a to the 3 times b minus a to the 4. We want to simplify this division. Okay, the first thing, you just rewrite this, but you know that in the future you are supposed to factorize, so do them in parallel, just for simplicity of writing. So what I do, I will write the first one, but in factorized form, if I can do it in my head. This is not hard, by the way. I can write it in the factorized form immediately. That's the conjugate rule, yes? The square root of the first one minus the square root of the second one multiplied by the square root of the first one plus the square root of the second one. And in the denominator, I factor 1a out. Yes, but the only point that you need to remember here, you change this to multiplication, but remember, you have to swap these two. So this will go to the numerator. I can pull a to the 3 out. This will go to the denominator. Apparently, I cannot do anything with that, and I don't need to do anything with that because I can see that they can be cancelled out. Okay, and everything is simple. Can I simplify vertically? No. Can I simplify vertically? No. In a cross manner way? Yes, because this one can be crossed over with this denominator, and this one can be crossed over with that numerator. There's also another one. This one can be taken out. Here, there are 2 of them left. So then I start because now there is no division anymore. That's multiplication. So I multiply the numerators, which are left over. A squared and this are left. And then nothing left. Nothing means 1, 1, and 1, by the way. Okay. And then I prefer to multiply it back if I cannot do anything. That's up to you. So 2a squared x plus 3a to the 4. So this expression can be drastically simplified to that expression. When I was at your age, I really loved to do this. Yes, it's very interesting. I would consider this an art. By the way, there are very, very complicated ones. We don't have time that I can go through them, but every now and then I can give you some examples to challenge you a little bit. Okay, so there are 2 main things left from this lesson, addition and subtraction. Okay, but of course I will do some more practice on divisions before starting the new lesson. Any questions? Okay, thank you.